Hello, Red Hat. I'm excited to be here today to help you get started on the Day of Learning Hackathon with the CRIS project. Let me introduce you to the project board in GitHub. You may have received an invitation to join the Red Hat Impact organization in GitHub, rh-impact. Here, we have a project board. If you click on projects and go to the Red Hat PNT Day of Learning 2022 Hackathon, you can get started right here. You'll see that we've split up the columns into many different individual open source applications. For example, DataLad. You can learn more about DataLad. You can do a quick Google search and learn that it's a free and open source distributed data management system that keeps track of your data, creates structure, ensures reproducibility. So that's an example of an application that you could research and help the CRIS project learn more about how it can help their organization build medical imaging apps and other tools to process files for medical purposes. Now, we're going to work through an actual example today. I want to show you, so I'm going to go across these columns here to FFmpeg, for example. And FFmpeg is a video processing library. So if I was going to join the hackathon and I wanted to choose a technical task, people can help create the actual Git repo and manage the repo and pull requests for it, or create documentation for how FFmpeg can help the CRIS project if you're non-technical, or for technical resources, you can go to the technical task to containerize and deploy the application. So if I click on this, I can go and assign this to myself. And then on the board, if I refresh, go to FFmpeg, you'll see that that's now assigned to me. This is how you can self-assign tasks and become part of a team. So I would be on team FFmpeg here, for example, because I assigned myself this task. Now we're going to work through an actual example of how this might work. So I have a brand new RHEL 9 virtual machine here that we can try out some documentation. And I have 3 links: a cookie cutter CRIS app quick start, an example of creating a custom command container, and some additional documentation about building cookie cutters. Well, let's start with a quick start, because this is really helpful here. First, it says to install Python. Let's pull up a terminal, and we should have Python available here in RHEL. We do. Now I'm going to set up a virtual environment because I'm a Python developer, and I've learned that if I pip install virtual env, then I can set up a separate virtual environment that won't mess with my system Python and its dependencies. So I have virtual env command now. I can type virtual env Python to create a new Python right in my home directory. Okay, that was created. Now I can source Python bin activate. And now when I type which Python, it shows that it's in my home directory /python/bin/python, and which pip is also there. Now I can go in and pip install cookie cutter and grab that cookie cutter tool. It says to run the command cookie cutter, which is now available on my system, cookie cutter space, and then a URL to a repository. What this does is asks a series of questions to set up a new repo for Chris plugin development. Let's answer these questions. Author name will be computate. That's my GitHub username. Author email, computate@computate.org. And repo name, they like to have them start with PL for plugin. PL-ffmpeg. And the app name will be ffmpeg, and Python class name will be ffmpeg with a big F. And the app type will be DS by default. That's what they recommend. App title, Chris. Plugin for ffmpeg. Leave categories blank for now. Description. What I want this to do is convert video files to animated GIFs. That sounds like fun. We'll skip the documentation link for now. Version 0.1 is fine. We'll test automatically, publish automatically, and choose the Linux AMD 64 platform, and we're done. That wasn't too hard. The rest is about uploading it to GitHub. So let's get into the technical details. Let's see what's in here. If I cd into ffmpeg, it's pl-ffmpeg, do tree. You'll see that we have a Docker file so that it's containerized. We have a Python module here called ffmpeg with a main method and some tests. And we have a license, a README, some Python requirements, and stuff to set up the Python project. This is great. Let's take a look at the Docker file. And there's not much to this. There's some comments. We use a base Python container image. We labeled it to myself. We start in this directory and we copy the requirements file, the Python requirements, to install, and we install those requirements. We copy the source code and we install the source code. And then we run the command ffmpeg --help by default. Now ffmpeg is this directory here called ffmpeg, and it has an init py, which makes it a Python module. It has a __ main.py. This is the main method. It calls another method called main, which constructs a new ffmpeg object and then calls its launch method. Simple enough. In the ffmpeg.py, I'm going to edit this one. We import some things. I'm going to add an import to this to copy files from one directory to another, because that's what these plugins are all about. It always takes an input directory and does some processing on the files to produce files in an output directory. So let's do a quick example. If I say from dist utils.dir _util, import copy _tree, and then down here after the description of the command line arguments or container arguments, in this run method, we can do more than just print the version. We can log some data. I'm going to do print %s to %s, and then put in the options.input_dir, options.output_dir. Close those parentheses. And then we do the copy tree method options.input_dir, options.output_dir. And that's simple enough. This should copy files from an input directory to an output directory. Let's go and create those directories. Let me follow a little bit more instructions here. It says to install Docker. We don't have Docker in RHEL 9, so we're going to use podman instead. We can type podman, and it says this command's not found, so do you want to install it? Yes. Yes. We're going to install podman real quick here, so that we can run this container. And while we're doing that, we're in the PL/FFmpeg directory. Let's make in directory and out directory. Great. One more thing, in the in directory, let's make a file called test.txt. Type, this is a test, hello world. And close that. Okay. All right, I think we're good to go now. Let's check out the README, which explains how to do a build of the container, but instead of Docker, we're going to do podman build -t local /pl-ffmpeg. I'm going to change this to computate because I have my own quay.io space that's called computate that I can push this container to. So we'll do a build. It's running that Docker file right now and installing the Python stuff. Great. Now let's look at the README again because it suggests how to run this. We do podman run --rm so that it doesn't store the container image after it runs. We don't need to do the -u because podman's already running as a user by default. We need to mount two volumes. The in directory that we just made to the incoming directory on the container, and then the out directory that we made to the outgoing directory on the container. That's important. So we have that, and then the name of the image that we built, which for me was called computate, oops, we need a space, /pl-ffmpeg. It's going to run the ffmpeg command, and then finally we need to specify the incoming directory and the outgoing directory on the container side. And let's pull up some files here so that we can see. We have test.txt in the in directory. We want it to appear in the out directory. So let's try running this. Oh, we got a permission denied error. Now, not all Linux operating systems are as secure as RHEL, so we have to be more flexible here to allow a privileged operation. We add a run -- privileged parameter, and when we run this again, whoops, I didn't spell privileged right. Privileged. It says it's copying incoming to outgoing, and sure enough, there it is. It worked. Isn't that awesome? Okay, that was not a very fancy example. Should we get fancier? Should we do something even more interesting? Let's try using the actual ffmpeg command now. We're going to update the Docker file, and we need to add an additional run command here to run apt-get install. No, first we need to do an update, because this is a Debian Linux container. Then we run apt-get, let's see, I'm going to add a -y install. Whoops, I spelled that wrong. apt-get -y install ffmpeg. And then we'll be able to run the ffmpeg command. Now we're going to update the Python code as well. We no longer need to use this copy tree, but we needed some additional imports. We'll import subprocess. And here's where I'll introduce you to my working example. Well, it's not mine, but I'll share this link to the pl-dcm2nix repo, because they have an example of parsing command line arguments and running that command as a subprocess. In Python, import subprocess and OS for file operations and RE for regular expressions. Then, in this run method, we're no longer going to copy files. Instead, we're going to convert videos here to animated GIFs here. Now, I've downloaded some Star Wars clips, and I want to copy these. These are video files. We're going to go to Home, PLFFmpeg. Paste these here, and I'm going to delete test.txt. Then we are going to iterate for each file name in os.listdir options.inputdir. For each of those, we're going to create an input path equals os.path.join options.inputdir, comma, file name, and a similar output path out, which is join of outputdir, but we're not going to do the same file name. We need to do some regular expression substitution on, it's going to be \w for word plus $ to be the end of the file name. We'll replace that with a .gif and add an extra parenthesis. Now we have the input path and the output path. Next, we'll set up a parser equals, oh, we forgot some imports. Let's do from arg parse import argument parser, comma, namespace, comma, argument defaults help formatter. And down here, do parser equals argument parser parses ffmpeg command. Now this example is straight out of this repo here. So you'll have that example. Description formatter underscore class equals argument defaults help formatter. Then we can do parser dot add argument, because the format of an ffmpeg command is ffmpeg-i to specify the input file, input path. Oops, that's not a Python comment. Input path, and then the output path. It's very simple. There's a lot of other arguments you can add to make it fancier. We'll keep it simple here. -i type equals str for string, help equals input path. Close that parenthesis. Add a similar argument, except call this output path. Type stir output path. Great. Next, we'll construct the command equals, I believe this command is in user local bin ffmpeg, but we'll make sure that in a second when we run this container. Comma, -i, and then put in the input path, and then the output path. And then we call subprocess.run cmd, comma, check equals true with the big T. I believe that will do it. Let's try it out. Yes, we're going to do a build. It should pull in the ffmpeg command after updating its apt-get packages. And it built. Now let's try the run command, except before we run it, I want to validate that we have the right executable -it. So user local bin ffmpeg, there it is. Oh. Cool. Because I noticed from doing this before, if you run ffmpeg without the full path, then it references this Python module instead. So this is the Python output, and this is the package. But yeah, it's going to work. So let's get out of here and let's run this again. Now we have these video files in the in directory. Let's take a look at the out directory now and see what happens. Run. I'm going to run this to convert the videos in the input directory to the output directory. Now we have an error, so let's resolve this real quick. Oh, sorry. I did the wrong. Let's look at this again. User bin ffmpeg. Okay, I'm wrong again. It should be actually this directory, so we built it wrong. So let's fix that. See if I run, that's why I was confused. If I run this, then it's got the right output. If I run user local bin ffmpeg, it got installed here. So it's an actual command, Python. Okay, but you're learning with me, I hope. ffmpeg.py. So this is not user local bin, this is user bin ffmpeg. And we're going to build this one more time. It's okay to make mistakes. We all do. Just try again. Now we have a newly rebuilt container. Let's run this. Oh, it's working. It's working. Check it out. It completed. Isn't this fun? Now let's just see this real quick. Oh, there's an animated GIF. There's an animated GIF. There's one. Oh, watch out. Ah, this is so fun. Oh, poor Luke. No. Okay, this is so cool. So we got it. It worked. Everything worked. It converted those videos to animated GIFs. So I hope this was helpful. This is an example. Now I'm going to go back to ffmpeg here and unassign myself from this task because I want you to have all the fun now. And that's an example of how to get started. Hopefully that is helpful. We'll send out all of these links so that you can get connected to the more advanced information about cookie cutters and an example of running one with a command and the quick start. So have a great time during that hackathon. I'll be there too. And thank you for watching. Have a great day.